Hi guys, welcome back. In this video, we are being solving this problem from thermophysics. So we have an insulated cylinder is divided into three parts A, B and C. Piston 1 and 2 are connected by a rigid rod and can slide without friction inside the cylinder. Piston 1 is perfectly conducting while piston 2 is perfectly insulating. Equal quantity of an ideal gas is filled in three compartments and the state of gas in every part is same. So adiabatic exponent of the gas is 1.5. The compartment is slowly given the heat through a heater H such that the final volume of the gas in part C becomes 4V0 by 9. So we have to find these three parts. Alright. So first we find the final values of all these: pressure, volume, temperature. So we know as C is an adiabatic process, neither heat enters nor releases. So first we write the condition of adiabatic process: PV power gamma equal to constant. From this we can find final pressure of C. So P0 V0 power gamma equals PC times 4 V0 by 9 whole power gamma. From this we got value of the pressure of C. PC equals 27 by 8 times P0. So we assume this as equation 1. So as we write the FBD of the rigid rod and two pistons, so this is the pressure from C and this is the pressure from A. So both are equal. So both are staying equilibrium as well. So PA equals PC. From this we can find pressure of A, that is equal to pressure of C also. So for A, volume of A equals V0 plus 5 V0 by 9. So how this came means, so as final volume of C becomes 4 V0 by 9 here, so it loses 1 minus 4 by 9 times V0. So finally 5 V0 by 9. So it loses 5 V0 by 9 volume. Okay, so that 5 V0 by volume gains a piston. So basically B is in constant volume. So why? Because it is a rigid rod as well. Alright. So from this we can find volume of A. Volume of A equals 14 by 9 V0. So we conserve number of moles here to find the final temperature of A. So P0 V0 by T0 equals 27 by 8 P0 into 14 by 9 V0 by temperature of A. So from this we can find temperature of A. Temperature of A equals 27 by 4 T0. So for B we write equations. Volume of B equals V0, so it is constant here, and we conserve number of moles to find the pressure of B here. So it is no work, but we have to find P0 V0 by T0 equals PB into V0 by 21 by 4 times T0. So the final pressure of B equals 21 by 4 times P0. So in the first part of the question, calculate the heat supplied by the heater. Basically the heat first enters into Q and goes into A. So it doesn't go into C because it is an adiabatic piston, insulating piston as well. So this piston is thermally conducting piston. So the temperatures in both compartments is same. TA equals TB here. So it is a key point. Alright. So yeah. Here work done by A equals minus work done by C. So why this is actually work done by B is 0, as we know volume is constant here. So as the piston displaces right, piston 1 displaces right, it does the positive work, and piston 2 compresses the C compartment, so it does the negative work. So work done by A equals negative work done of C here. And then we write first law of thermodynamic equation. So heat equals delta U of A plus B plus work done by A. Here we doesn't include work done by C because it doesn't participate in the heat. Alright. So I considered here 2 moles. So 1 mole of A compartment and another mole is B compartment. 2 and C with delta T plus minus. So here work done by equals minus work done of C. So minus of work done by C I wrote here. So after substituting the values, that simplifies. Heat given by the heater is 18 times P0 V0. So the B part of the question asks calculate the amount of heat flow through piston 1. So B part is pretty easy. So heat flow through piston 1 is delta U of A plus work done by A. As we know, work done by A is P naught V naught. So actually here we wrote delta U of A plus B. If we divide it by 2, we got delta U of A. So 17 P naught V naught by 2 plus P naught V naught. From this we got heat given by the piston A is 19 by 2 P naught V naught. So guys, comment the answer of C part in the comment box. So if you have any doubts, please comment below. I'll answer it. So thanks for watching.